Ever wished you had a crystal ball for your business? A way to actually see what's coming around the corner? Well, what if I told you that you don't really need magic, just a little bit of math? Today, we're going to unlock a powerful toolkit for looking into the future. And trust me, this isn't about dry statistics. It's about turning raw numbers into real, actionable foresight.
So let's just jump right in. Every single organization out there, I don't care if it's a tiny startup or a huge corporation, faces the exact same problem. How do you plan for a future you can't see? How do they decide how much stuff to order, how many people to hire, or where to put their money? Well, it really boils down to two main approaches. On one side, you've got intuition, that gut feeling, the wisdom a manager gets from years of experience, and that is super valuable. But on the other side, you've got the cold, hard data. And today, we're going to focus on how that data, using mathematical models, gives us a really powerful analytical edge. And believe me, it's a critical edge to have. Because these forecasts, they're not just some academic exercise. They are the absolute foundation for business plans, for budgets, for pretty much every major decision a company has to make. Getting this right, it's everything.
So, where do we start? Well, before we can predict anything, we first have to find a pattern. We need to figure out if two things are even related to each other at all. And that first tool in our kit is called correlation. So, correlation gives us this one really powerful number. It's called the coefficient of correlation, but everyone just calls it R. Think of R as a simple score that goes from -1 all the way up to +1. The closer that number is to either -1 or +1, the stronger the connection. It tells us just how tightly two things move together in a straight line. And check this out. This slide shows you the two extremes perfectly. Over on the left, an R of +1. That's a perfect direct relationship. When one thing goes up, the other goes up in perfect lockstep. Now, on the right, an R of -1 is the total opposite, a perfect inverse relationship. As one thing goes up, the other goes down. Again, perfectly. Think about the gas in your tank and the miles you've driven. That's a perfect inverse link. Of course, the real world is usually a lot messier, right? The graph on the left shows an R of 0.7. That's a strong positive relationship for sure, but it's not perfect. The dots are kind of clustered together, but they're not in a perfect line. Now, the graph on the right is super important. An R of 0 doesn't mean there's no relationship at all. It just means there's no straight line relationship. The data might follow a curve or some other pattern that R just isn't built to detect. Okay, now we can take this a step further with something called the coefficient of determination, or R squared. It's simple. You just square your R value. What it tells you is the percentage of change in one thing that can be explained by the other. So let's say the R between advertising and sales is 0.8. Well, R squared is 0.64. That means 64% of the change in your sales can be explained by your advertising budget. That's huge. It tells you that advertising is a major factor, but there's still 36% of a story you're missing. It literally quantifies what you know and what you don't. So correlation is fantastic for finding a relationship. But just knowing two things are connected, that's not a forecast, right? How do we actually use that connection to predict the future? For that, we need our second tool. We need to build a model. And that's where regression comes in. And it all starts with this simple formula. Now, don't let the letters scare you off. All this is a recipe for a straight line. Y is the thing we want to predict, like sales, and X is the thing we already know, like how much we spent on ads. The regression analysis does all the heavy lifting. It calculates the perfect numbers for A and B to draw the single best line through all of our data points. Okay, let's look at a real-world example. So a company collected its data from the last few years. On the left, you see what they spent on advertising. On the right, you see their annual sales. They can look at this and kind of feel like there's a connection. But what is it exactly? How strong is it? And boom, this is what happens next. The analysis draws the one single line that best fits the trend in that data. All of a sudden, we have a visual model. We can clearly see a positive relationship. The more you spend on ads, the higher the sales. It takes the messy chaos of the real world and gives us a clear pattern. So here's the really cool part. The analysis gives us a specific formula. Now the company can work backward. Let's say they want to hit $32 million in sales next year. They just plug that number into the formula and solve for X, the advertising spend. And the result? They now have a data-driven projection that they'll need to spend about $89,000 to hit their goal. Just like that, You've gone from a table of old numbers to a concrete plan for the future. That's how you turn data into a decision. Now, these tools are incredibly powerful, but, and this is a big but, they're not magic wands. To use them responsibly, you absolutely have to understand their limitations. And honestly, this is just as important as knowing how to use them in the first place. And here it is, the golden rule. The single most important thing to remember from all of this: correlation does not equal causation. I'm going to say it again. Just because two things move together does not mean one is causing the other to happen. This is my favorite example because it just makes the point so perfectly. Okay, car wash sales and sunny days are strongly correlated. But no matter how many cars you wash, it's not going to make the sun shine, right? There's a hidden factor at play. People just like washing their cars when it's sunny. One doesn't cause the other. You also have to keep a couple of other key things in mind. First, your predictions are really only reliable inside the range of your original data. So if your model was built on ad budgets between $30,000 and $70,000, you can't really use it to predict what happens if you spend $1 million. You're stretching it too far. And second, the whole thing assumes the future will basically look like the past. And, well, we all know that's not always a safe bet.
All right, time for a quick pop quiz to see if you've been paying attention. Looking at these 4 correlation coefficients, which R-value here points to the weakest linear relationship between two things? Take a second. Think about it.
The answer is negative 0.11. So why is that? Because the weakest relationship is always the one with the R value that's closest to 0. It doesn't matter if it's positive or negative. The plus or minus sign just tells you the direction of the relationship, not how strong it is. So now it's your turn. Take a look at the data in your world. What hidden relationships are just waiting for you to find them?